Hi children, we continue with our fifth chapter, periodic classification of elements. In the last class we discussed about the trends in the modern periodic table. About two properties we already completed our discussion, like valency and atomic size. Now we move on to the third property, metallic and non-metallic properties. Metallic and non-metallic properties. So, in the modern periodic table, metals are seen at the left hand side. Left hand side of the modern periodic table we can see metals. On the right hand side of the periodic table we can see non-metals. Metals are given green color. We can see that all metals are coming in the left hand side of the periodic table with the exception of hydrogen. Hydrogen, as you know, is a special or a unique element. Now non-metals are given yellow color and they are found on the right hand side of the periodic table. And now you can see a zigzag line between metals, separating metals from non-metals. We can see a zigzag line, and these elements are known as, these borderline elements are known as metalloids or semi-metals. They have intermediate properties. They have some properties of metals and some properties of non-metals. We call them as metalloids or semi-metals. Okay, so on the left hand side of the periodic table we can see metals, and on the right hand side of the periodic table we can see non-metals. Separating metals from non-metals, there is a zigzag line. The elements on either side of the zigzag line, they are known as the borderline elements, which have intermediate properties between metals and non-metals. Some properties of metals, some properties of non-metals. We call them as metalloids or semi-metals. Boron, silicon, arsenic, antimony, germanium, etc. The names of the metalloids we have already learned in 9th standard. Okay. Now, what is metallic property? Under valency we have learned that metals have 1, 2 or 3 valence electrons. Metals have 1, 2 or 3 valence electrons. So, what is their general tendency? They have a tendency to lose electrons. They have a tendency to lose electron to get the configuration of the nearest noble gases. When electrons are lost, what type of ions are formed? When electrons are lost, positive ions are formed. When electrons are lost, positive ions are formed. Electrons are lost. Naturally, the atom will be having excess of positive charges. So, positive ions are formed. This you have learned in chapter 3, ionic bond formation. So, when electrons are lost, positive ions are formed. So, metals have a tendency to lose electron and form positive ions. This property is known as electropositive nature. So, metallic property is also known as electropositive nature or electropositive character. What happens to metallic character as you move down the group? When you move down the group, what happens to metallic character? In the previous class, we saw that as you move down the group, size of the atom increases. As you move down the group, size of the atom increases. Distance between the center of the nucleus and outermost shell increases, or outermost electron will be far away from the nucleus. As you move down the group, outermost electron become far away from the nucleus. So, what happens? This metallic character. What is metallic character? Tendency to lose electron. What happens to metallic character as you move down the group? Down the group, metallic character increases. Metallic character increases down the group because the effective nuclear charge, power of the nucleus, the pull of the nucleus experienced by the outermost electron will be less. The reason is outermost, as you move down one by one, you are moving from one element to other, outermost electron become far away from the nucleus. So, the effective nuclear charge experienced by the outermost electron will be less. So, those electrons can be lost easily. Nucleus will not be having that much effect on this outermost electron as the size increases. So, the electrons can be easily lost. Losing electron, that tendency is called metallic character. So, as you move down the group, metallic character increases. On the other hand, as you move from left to right in a period, left to right, what happens to the size? Size decreases. Effective nuclear charge experienced by the outermost electron will be more. So, the nucleus will not allow these electrons to be lost very easily. So, what happens to metallic character? Metallic character decreases there. Metallic character decreases. Electrons cannot be lost easily. So, metallic character decreases as you move from left to right in a period. Across down a group, metallic character increases, and across a period metallic character decreases. Okay. So, that is metallic character. Metallic character is also known as electropositive character. Down the group it increases, across a period it decreases. Reason you have to learn. Down the group the effective nuclear charge experienced by the valence electron will be less. So, electrons can be lost easily. Electrons losing easily, that is called metallic property. So, it increases. But across a period size will be decreasing. So, the nuclear charge experienced by the outermost electron will be more. So, the nucleus will not allow these electrons to be lost easily. So, metallic character decreases. Okay. Now, coming to non-metals. What is the general tendency of non-metals? Non-metals have a tendency to gain electron. Non-metals have 5, 6 or 7 valence electron. So, they have a general tendency to gain electron to get the configuration of the nearest noble gas. Okay. So, this character, when electrons are gained, what type of ions are formed? Negative ions are formed. When electrons are gained, more negative charge is attained. So, negative ions are formed. This character is known as electronegative character. Non-metallic character is also known as electronegative nature or electronegative character. What happens to electronegative character down the group? Down the group we have already seen. As you move down the group, it is metallic property that is increasing. Metallic property increases. So, non-metallic character will be decreasing down the group. Non-metallic character decreases down the group. Non-metallic character is the tendency to gain electron. Tendency to gain electron will be less as you move down the group because the effective nuclear charge will be less. So, electrons cannot be pulled. Electrons cannot be attracted closer towards the nucleus. Electrons cannot be gained easily. Size is more, so effective nuclear charge is also, size is more, so effective nuclear charge is less. So, electrons cannot be gained easily. So, down the group electronegative character or non-metallic character decreases. But as you move from left to right, we can see that non-metallic character increases. Non-metallic character increases because the effective nuclear charge experienced by the outermost electron will be more. The nucleus will be having a tendency to pull, attract more electrons closer, gaining more electron towards it. So, electronegative character increases. Okay, electronegative character increases across a period and decreases across down a group. Metallic character on the other hand decreases across a period and increases down the group. Metallic character is also known as electropositive character. Non-metallic character is known as electronegative character. Okay, now our next topic is how to find out the position of an atom. How to find the position of an element. Position of an element means to find in which period and which group this element is placed. If the atomic number of the element is given, for example, atomic number of the element is given as 13. Atomic number is given as 13. Only that is given. How will you find the position of the element? You have to say in which group and which period the element is placed. Okay. For that, first you have to write the electronic configuration. The first thing is write the electronic configuration. So, that is the first step. Write electronic configuration. Write the electronic configuration of the element. That is the first step. Then, period number means you have to find out in which period it is placed. Number of shells. Period number is equal to the number of, period number equals the number of shells. Count how many shells are there. Here how many shells are there? 3. So, which period this element belongs to? To which period this element belongs to? Period 3. Okay, so first write the electronic configuration. Count the number of shells. Number of shells corresponds to its period number. So, period number is 3. Then group number. Now, you have to find the group number. For that you have to check the number of valence electron. If number of valence electron is 1 or 2, if the number of valence electron is 1 or 2, that is the group number. With the exception of hydrogen and helium. Hydrogen is a unique element, helium is a noble gas. So, with the exception of hydrogen and helium, we can say that first you write the electronic configuration. Write the electronic configuration, count the number of shells that corresponds to the period number. Next is we have to find out the group number. For that, look at the number of valence electron. If it is 1 or 2, that is the group number. Group number is 1 or 2. Number of valence electron and group number will be same for 1 and 2. If it is 3 to 8, then we have to add number of valence electron plus 10. You have to add 10 to the number of valence electron. You have to add 10 to the number of valence electron. I hope it is clear to you. First thing is writing the electronic configuration. Count the number of shells. How many shells are there? That is the period number. Now to find the group number, look at the number of valence electron. Look at the number of valence electron. If it is 1 or 2, that is the group number also. Number of valence electron and group number is the same with the exception of hydrogen and helium. Hydrogen has 1 electron but it doesn't belong to any of the groups of the periodic table. Helium has configuration 2. Helium has configuration 2 but it is not an element of second group. It is a noble gas. So, with the exception of helium and hydrogen, all other elements, if the number of valence electron is 1 or 2, their group number is also same. Then if the number of valence electron is 3 to 8, you have to add 10 to that. Then you will get the group number. Now take this element, its period number we have already written. 3 shells, 2, 8, 3, K, L. Three shells are there, K, L and M. 3 shells, so its period number is 3. Now we have to find out the group number of this element. Okay, how many electrons are there in the valence shell? It is 3. So, what you have to do? Add plus 10. So, group number is 13. Okay, 3 to 8 you have to add plus 10. Now, here it becomes 13. 3 plus 10 making it 13. I hope it is clear to you how to find out the period number and group number. Now, we will do a question. An element X belongs to the third period and group 13 of the periodic table. Determine the number of valence electron and the valency of X. Here what is given is period number and group number. Period number is 3 and group number is 13. From that, how will you identify the element X? How will you identify the element X? Period number 3 means how many shells are there? 3 shells, K, L, M. It shows that period number 3 means it has 3 shells. Now the group number is given, group 13 is given, group 13. So how many electrons are there in the valence shell? From the group number you will get an idea about the number of valence electron. Group number 13 means it has 3 electrons in the valence shell. That's how group number becomes 13, 3 plus 10. So, 3 electrons in the valence shell. If there are 3 electrons in M shell, before that K and L are filled, isn't it? Only after filling K and L shell, we move on to the M shell. So, it shows that its configuration is 283. Its configuration is 283. Now, look at the first question. Determine the number of valence electron. How many valence electrons are there? 3. What is the valency? Valency is also 3. Number of valence electron is 3. That means valency is also 3. By losing these 3 valence electron, it can get the configuration of neon. Okay. Now, second part of the question. The molecular formula of the compound formed when X reacts with element Y. Okay. So, we have our X. What is the valency of X? Valency of X is 3. Now, Y. We have learned in 9th standard how to write the formula. So, X has valency, write X, below that write its valency. Now, Y is there, Y atomic number is given, so its configuration is 2, 6. 2, 6. What is its valency? Its valency will be 2. It needs 2 more electrons to get the configuration of neon. So, its valency is 2. Now, cross over the valencies. What do you get? X2, Y 3, X2, Y3. So this is how we find out the molecular formula of the compounds. Any way the question may come. Sometimes the atomic number will be given, directly you find out the position. Here the position is given, you have to answer other question. If the position is given, you can find out the atomic number of the element. Period number gives number of shells. From the group number you will get an idea about number of valence electron. So that's how you write the electronic configuration of the element, then find out the element and write the formula of the compounds formed from it. That's all. With that, our 5th chapter is over. Thank you, children.